str in both cases here, I don't have to put a splat, a dereference, or anything like that, because we know str holds the address of something, doesn't it? Something else. It's actually going back to, it's a reference to the original variable, which is this one that we called here. Now, does anybody in here believe that str here and str there is one and the same variable? Anybody in here believe that? I hope you don't. Convince yourself by saying, oh, let's change this one right here to str1 and call str, or call getString with str1, and everything will work just the same. Okay, this str up in the prototype and this str are not the same variable. They're very different. Okay, questions there on any of that material? So when we do this passing pointers by reference, we don't have to worry about any extra splats. But if we wanted to pass by, now what is this one called? Oh, this is pass by pointer. Pass by pointer. Notice that we've replaced the splat with, excuse me, we replaced the ampersand with a splat. Action here is exactly the same as what we just described. However, notice when we make the call, we have an ampersand in front of str, which says pass over to getString the address of str. That is this str right here. And then when we come into here, we've got this double splat. Oh my gosh, the world just got really complicated. What do I do with that? Well, remember that, whoops. This much is the base data type, isn't it? It's the base data type. It's an address of a character. The other piece, the splat, is an indication that we are passing by pointer. So str holds the address. This str holds the address of the other str. Therefore, when we make this assignment of the newly allocated memory that we just talked about, we have to put the splat in front. If we don't, if we left that off, what would happen? Well, this would execute, no problem. This would execute, no problem. But now, when we come back to here, you're going to say, but Mr. Metzler didn't print out my string. I entered it, I ran it, it all compiled just fine, but it didn't print out my string here on this line. And my response to you is, well, that's because here you were pointing to the local variable. You were just modifying what amounts to a local variable. You weren't referring to, you weren't assigning to the called or the variable in main. So this says, putting a splat here in front, simply says, I want the address that I passed in, Likewise, when I do the string copy, I want the copy to be to that address. Okay, questions here? All see that? No problems? Pass by reference, pass by pointer, doing exactly the same thing. However, pass by pointer requires a little extra work. The previous one, pass by reference simply says, I don't need to. Behind the scenes, I'll do it for you. Okay. It says an array can never appear on the left side of an assignment because it's a constant address. A pointer is a variable that can appear on the left side of an assignment operator. So we have these two pointer declarations, and it says assign that to there. What actually gets assigned into str1? What actually gets assigned in str1? What about the memory? Where's the memory that where Sherry is held? Where is it?
In the memory.
Okay.
Dynamically
Sherry
allocated.
is a string literal, isn't it? String literal. And as such, it's a constant, and there is a thing called a constant table that the C compiler creates, constructs, and makes available to you, to your running program. So str1 now holds the address in the constant table of Sherry. So the question becomes, str1 and str2, are they pointing to the same address? They're both Sherry, they're spelt exactly the same. And what is it? Depends on the compiler. Some compilers optimize and say, oh, Sherry, that looks just like the string I've already placed in the constant table. Other compilers say, oh, Sherry, here's a constant, stick it in there. Here's another constant, create another entry in the constant table. Don't bother to look as to whether or not they're duplicates. Visual Studio C++ compiler will create two entries. So comparing str1 and str2 without dereferencing will give us different addresses. They won't be the same because they're stored at different locations. So we would have to do a string compare in order to recognize that they are in fact the same. All right. Here's an interesting one. This will crash your program where you're trying to delete a constant. Delete a constant, returning it back to the dynamic allocated heap area is what we do when we delete, but if it was never there to begin with, we're going to have a problem. Okay. So this statement is perfectly legal, isn't it? Right? This next one is perfectly legal, and so is the third one. The question now is, is that one legal? Oops, let me go back and change that to lowercase n. Is that legal? Can I do that? Actually, this is a constant, isn't it? Different, and if it was in Visual Studio, and I made this a capital P, it would be just like this. It's another string literal constant. So there's going to be an entry created here for that. That's not a problem. What about this? Tyler, is that legal? Can I do that?
Do what?
Name
Oh,
one
oh, name
is
one.
the name of the first array up there.
Uh-huh.
That's perfectly legal. Name two
Oh, no, because
gets
that's,
Peggy.
That's
That's perfectly legal. Name three gets Peggy. That's perfectly legal. Name one gets Peggy. Legal or not?
I don't think so.
No, and why not?
Because
Why not?
Name one is a constant address and not a
So I can't change what name one points at. I can only initialize what name one points at. Initialization is not assignment. That's really the point here. Do you understand that? Really subtle difference, perhaps. We know that name one and name two are both pointers. We know that name three is a pointer. But these two pointers, name one and name two, are constant pointers. Name three is a variable pointer, so I can change what name three points at anytime I want to. Okay? But I can't change what name one points at. I can't change it. I can only initialize it. Now, I can string copy over Peggy and put Susie in there if I want to, right? I can string copy different characters in that same location. I can do that. But I can't do a